The Bantam planet Pluto is the farthest object in our planetary group. Many huge numbers of minor frosty planets and space rocks populate this district of space inside the Kuiper belt. Once remembered to be the 10th planet in our planetary group, Pluto was named after Pluto, the Roman lord of the hidden world. However, Pluto lost this status in 2006. According to current scientific hypotheses, the solar system contains incalculable space rocks, a modest number of Bantam planets, and just 8 planets. Our understanding of the universe has expanded extraordinarily over the recent hundreds of years, and we now have a smart idea of how planets work, what they're made of, and whether they may house humanity in the far future. Yet, maybe there is still an incredible amount to discover about the stars in our own universe. What secrets has the James Webb Space Telescope finally addressed about Pluto? Does it harbor life, either known or unknown? Does it have an inner sea? Join us as we explore the staggering mystery of what the James Webb Space Telescope has found on Pluto, which was concealed in and around the 10th planet. Pluto was greatly appreciated for many years. People noted that it had the smallest moon in the nearby planet group. The way its orbit was tilted and oval didn't trouble anybody. Pluto was somewhat of a crackpot, but it was our weirdo. Kids could connect with it because of its smallness, and many grown-ups could relate to its position as an outsider. The general public felt compelled to defend Pluto, and there was public shock when Pluto was renamed as a minor planet 15 years ago. It is perhaps not surprising that the International Astronomical Union, IAU, amended their definition of a planet and Pluto was left off the list. According to the revised criteria, a planet must have 3 qualities. It needs to orbit the Sun, it should be large enough that its own gravity can shape it into a circle or something close to one, and it must have cleared its orbit of debris. Pluto failed the third and final test, so we have a Bantam planet. The term planet has been used in a much more extensive sense for centuries. During the 1600s, when Galileo trained his telescope on Jupiter, everyone thought any large orbiting object overhead was a planet. Indeed, even moons counted. When stargazers first discovered the rocky bodies we now refer to as asteroids during the 1800s, they also referred to them as planets. From the beginning, Pluto was viewed as a planet. It was first found in January 1930 by amateur astronomer Clyde Tombaugh, using photos taken with a telescope. Tombaugh announced his finding promptly to the observatory's head, saying, "I have found your planet X." Tombaugh was referring to a speculative 10th planet that would orbit the Sun beyond Neptune. However, things took an odd turn when it was discovered that Pluto was not alone in the universe. Beyond Pluto's orbit, in 1992, an object just a tenth as wide was found. Since then, nearly 2,000 frozen bodies have been discovered in the Kuiper belt, the coldest region of the solar system's edges. There could be significantly more to come. Questions were raised when it was found that Pluto had so many neighbors. What did these new planets share in common with Earth? Why did they stand out suddenly? Astronomers were confused about what constituted a planet. Professor Mike Brown, a planetary scientist at Caltech in Pasadena, found the first Kuiper belt object that appeared to be larger than Pluto in 2005. In celebration of the TV show Xena, Warrior Princess, its name was changed to Xena. This cold remnant was created when the Sun and planets were very young. Brown proposed that Xena should be the 10th planet, and if Pluto was the 10th, then Xena should also qualify. However, if Xena didn't merit the status of a planet, then neither did Pluto. In 2006, conflicts over where to place Pluto and Xena reached a boiling point. The matter was settled at a meeting of the International Astronomical Union in Prague. After extensive discussion, a revised definition of planet was proposed, and on the last day of the August meeting, Bantam planet status was granted to Pluto and Xena. Given its significance in stirring up how we understand the nearby planet group, the name is fitting. Because Brown's work contributed to Pluto's demotion, he has earned the Twitter handle Pluto Killer. Textbooks were quickly rewritten and updated. However, many planetary scientists have never updated their methods, and this is particularly true for those who focus on Pluto. This could be mockery or malignance on their part, But some, including myself, argue in two papers that there are also substantial reasons to reject the IAU's definition of a planet. The researchers read various books, articles, and letters to compile this information. Some of the papers were extremely old and illustrate the various manifestations through which the term planet has been used by scientists and the general public, and the reasons were not always clear. Between Mars and Jupiter, in the asteroid belt, you'll find this history. After its discovery in 1801, Ceres was given planet status alongside Pluto. As more objects were found in the asteroid belt, Ceres was said to have lost its planet status. It was determined that Ceres had many neighbors by the end of the 1800s. According to the legend, Ceres lost its planetary status because it was no longer unique. That is how Ceres and Pluto were similarly distressed. Brown's group now asserts that this is not the true story. Indeed, even until the 20th century, Ceres and other asteroids were still regarded as planets, albeit minor ones. A scientific bulletin reported in 1951 that a large number of planets are known to orbit our Sun, with the caveat that the vast majority of these planets were small fry, with sizes ranging from that of a city block to that of the state of Pennsylvania. It was only after the 1960s that minor planets became an offensive term. They were viewed by spacecraft for the first time by then. Planetary characteristics were still present in the largest asteroids, but most of the smaller ones were strange knots. This demonstrated they weren't just smaller versions of the larger round planets. The fact that asteroids often fail to escape their orbits is insignificant to the decision to rebrand them. What about moons, you may ask? Until the 1920s, they were referred to as planets or secondary planets by researchers. It's astounding that, despite scientific evidence to the contrary, the common practice of referring to moons as planets persists. Non-scientific media, such as celestial chronicles, were largely responsible for the shift. Horoscopes in these tomes are derived from the planetary arrangements, so astrologers insisted that keeping the number of planets overhead small was clearer. However, new data gathered through space exploration reintroduced moons to the planetary family, especially for some massive round ones, including moons. The term planet was used again in academic discussions. Distributions beginning in the 1960s, the Worldwide Galactic Association's meaning of planet is, in short, not the primary definition. The word has gone through various shifts in definition. In this way, it may very well be adjusted again if necessary. The IAU's definition is frequently protected because it keeps the number of planets from going crazy. What might your life resemble if the universe contained hundreds or thousands of planets? How might the average person still remember them all? What might we put on the lunch sacks? Interestingly, Simple stresses that focusing on just 8 planets will deter people from diving deeper into the universe. Maybe, in the end, the meaning of a planet is subjective. In 2015, when NASA's New Horizons spacecraft flew by Pluto, it revealed a planet with significantly more activity than anyone had anticipated, nitrogen bluffs suggestive of Norway's rugged coastline, and methane ice shards as tall as buildings can be found on the dwarf planet. The Earth is scarred by holes deeper than the Grand Canyon and frozen volcanoes towering higher than the Himalayas. The cameras on board the spacecraft photographed a gigantic heart-shaped feature on the distant globe, which made millions of fans on Earth faint. 8 years have passed since researchers got that first breathless sight, but they are still seeing the world through open-minded perspectives. Since New Horizons was going at 32,300 miles per hour when it made its closest approach to the dwarf planet, it was only able to take detailed photos of the side of Pluto that was pointing toward the Sun. One side was immediately hidden from view by darkness. Now that researchers have analyzed the close-ups of the near side taken by the spacecraft days before it dashed past, they are beginning to look at the pictures of the other half. Researchers refer to such a region as the far side or the dark side. Despite the low resolution, the photos clearly depict the scene with detail down to around 1 mile, that is, all things considered, multiple times more detailed than pictures caught by the Hubble Space Telescope, which orbits the Earth. Researchers now have a new perspective on this powerful world, thanks to the investigation of many pictures revealing insights into questions such as whether a sea lies underneath the icy covering and how mixtures freeze out of the air to shape the planet's surface. The measurements even lend credence to the possibility that the cold world could support life. However, there are secrets presented by the photos. For instance, the ice parts that look like high-rises were recently found on Pluto's far side, but they now seem to circle the planet. Because of this, their origins are among the dwarf planet's most prominent mysteries. Richard Binzel, a planetary researcher at the Massachusetts Institute of Technology in Cambridge and a New Horizons co-investigator, says Pluto is the gift that continues to give. In 1996, researchers were able to see surface details at a resolution of 310 miles, thanks to the Hubble Space Telescope. The photos were hazy, but they showed a planet-like globe with higher global contrast than any other planet in the nearby planetary system, including Earth. In July 2015, New Horizons notably observed a heart-shaped feature just north of the near-side's equator, affirming that Pluto is indeed a powerful world. Sputnik Planum, a frozen basin filled with enormous icebergs, is located within Pluto's left ventricle and is now known to significantly affect the planet's dynamic beats of sublimating ice, which rise high into the atmosphere as the sun warms the frozen plain, only to fall again when the warmth fades. This beating makes sunsets possible. Francis Nemo, a planetary researcher at the University of California, Santa Cruz, and his associates noticed something odd about Sputnik Planum not long after the first photos of Pluto's near side were sent to Earth. It is situated nearly entirely opposite Pluto's largest moon, Charon. The chance of a collision occurring is 5% at most. Nevertheless, simulations show that an underground ocean began to rise into the basin as the bowl was forming, with nitrogen gas from Pluto's atmosphere consolidating and freezing in the cold basin. Pluto's current arrangement is the consequence of a massive weight caused by the accumulation of extra water and ice. The idea of a sea underneath the surface isn't new, but the far side photographs have provided critical support for this hypothesis. Some of the most convincing evidence comes from turbulent landscapes, a confusing interweaving of slopes, cracks, and plains situated on Pluto's opposite side from Sputnik Planum. Researchers believe that an asteroid or comet impact caused seismic waves to tear through and around Mars, Mercury, and Europa, one of Jupiter's moons. When these quakes finally crashed on the opposite horizon, they tore the surface in a manner similar to what we see on Pluto's icy moon, Charon. Planetary researcher Oliver White from the SETI Institute in Mountain View, California, who didn't participate in the study but made a geological map of the far side, believes that the features appear to mirror those observed elsewhere in the nearby planetary system. However, given the low resolution of the images, a majority of other researchers share this assessment. Perhaps we won't know unless we make a return trip. The discovery of various cracks on Pluto's far side, among other geological characteristics, lends further intrigue to this distant world. Belief in the possibility of a subsurface sea on Pluto has intrigued researchers for quite some time. They have hypothesized that Pluto's sea had a viral start, implying that it was frozen when the dwarf planet was formed. Eventually, the radioactive decay in its rocky core would have generated enough heat to melt the ice. As it melted, the ice would have contracted, causing fracturing on the surface. This development of the ice as it froze would have led to surface cracking. If this is the case, then Pluto's surface ought to appear creased and cracked in recent photographs. However, New Horizons only captured images showing that the dwarf planet's sea was once liquid but has now partially frozen. For example, photographs of Pluto's far side show a massive crack that runs the length of the planet's near side. It has advanced to the point that it wraps around the whole dwarf planet, from the North Pole to the South Pole, on the opposite side, similar to the East African Rift System, which separates that continent into two. Pluto's fracture, rather than being evidence of moving continents like Earth's, is likely a scar from the freezing and ever-expanding sea. The age of the fissure indicates that the fluid sea quickly began to cool after being exposed to the air. If so, marine life could have thrived there. The dark red shade of the water suggests it is stained with organic molecules, seen in samples that likely spilled out of the sea on the near side. The intricate organic matter with a rosy brown hue has been created in the lab by radiation similar to solar wind or cosmic rays. Thus, it is possible that similar processes could occur on a world like Pluto. Ammonia permits the formation of molecules vital for life, like the bases found in RNA and DNA. The red ammonia ice on Pluto's near side is a significant indicator that the dwarf planet might be rich in organic compounds, a notion that has gained considerable support among planetary scientists. This does not imply that life began on Pluto, but rather that it could survive if given the right conditions. The far side measurements have done more than just guide the search for life on Pluto, they have also produced various mysteries. Researchers were astonished to see ice pieces the size of skyscrapers in the easternmost part of the near side in the initial photos sent back from the James Webb Space Telescope, some reaching heights of 1 mile, roughly 3 times the height of the Empire State Building in New York City. These edges are similarly distributed and rise sharply, forming knife-like peaks that may extend for 19 miles. It would be a nightmare to try to navigate around here. However, until scientists discover what lies on the opposite side of the planet, it remains a mere blip. The current map is murky, but it's easy to discern that the bladed geology continues around the whole perimeter, returning on the western edge of the near side. They are one of Pluto's significant secrets, as they span a region on the far side that is multiple times as large as their extent on the near side. High-altitude measurements show that the edges are made of methane ice, forming a belt around the equator. However, no one knows for certain how they originated. Perhaps, like ice on Earth, methane in the atmosphere hardened and fell to the ground. Maybe they are remnants of a layer of methane ice that intense sunlight has eroded. The sharp edges have led some scientists to consider the second chance, as they resemble structures that arise in the Andes, but on a much smaller scale. The penitents of South America are only a few meters high and form in hilly regions. Light is thought to play a role in the development of penitents, as they point toward the sun and develop near the equator, where solar radiation is most intense. Sublimation, the process that apparently cuts down box between edges as it carves, is thought to be driven by sunlight. One thing is certain, understanding the ice pieces in Pluto's landscape requires a deep dive into the dwarf planet's environment. The history of Pluto is significant of humanity's ceaseless quest for knowledge and the dynamic nature of our understanding of the universe. Meanwhile, scientists will refine existing climate models to better reflect observed anomalies. They need to attempt to reproduce the conditions of Pluto's environment and possible see in a lab. The James Webb Space Telescope will be pointed more directly at the minor planet. While it can't take high-resolution pictures of Pluto, it can utilize longer wavelengths and is therefore likely to uncover something unexpected. Now, we are left contemplating what